Good day, guys. Today we are starting in our first workbook on page 365. We'll be beginning our new unit on probability. Today we'll be working with creating sample spaces. You will discuss and learn how to prevent or how to understand events, outcomes, and create sample spaces. One way we're going to create sample space is by using a tree diagram. And all those will be discussed today throughout this lab. Now, our first question is the one you see on top of your page there on 365, and it says inquiry. How can I use multiple representations to determine the number of outcomes for an action? This may not make too much sense when you first read it. Multiple representations means doing different things or different ways. And you want to figure out the number of outcomes for an action. Well, action means something that you can do. Let's go ahead and continue reading the next two paragraphs. It says a number cube has 6 faces. When you roll a number cube, there are 6 possibilities. An outcome is any one of the possible results of an action. The set of all the possible outcomes is called the sample space. So, for example, the sample space is 1, 2, 3, 4, 5, 6. So let's start from the beginning of this paragraph. A number cube is what we call dice. But dice is plural. That usually means at least 2. So let's talk about a single die. And in math, they're always going to call that a number cube. So a number cube is basically a single die. And just like most playing dice, they're numbered 1 through 6. So the event, and this is a word I'm going to throw at you that's not on here, the event would be, or the action would be to roll a single dice. The outcome is anything that you can get that's on the dice. And most of the time, a single dice is numbered from 1 through 6. So if I said create a sample space of everything you can get when you roll a single die, you would say you can get the numbers 1, 2, 3, 4, 5, or 6. And this will become even more transparent and more obvious as we continue on. The next paragraph says, organized lists, tables, and tree diagrams can be used to represent the sample space. A tree diagram uses branches to show the total number of outcomes. So let's go ahead and discuss what a tree diagram is and how it's actually created. So here's our quote-unquote hands-on activity. I say that because I thought it was going to be like rolling dice and flipping coins, but actually it's more of a thought experiment. So it says, draw a tree diagram to determine the sample space when a coin is tossed and a number cube is rolled. So we're having 2 events now. We are flipping a coin and rolling a single number cube. Step 1, list the outcomes for tossing a coin. Well, we're all pretty familiar that with most coins or anything we flip, coins that we toss, we always call one side heads and one side tails. So when you first flip a coin, you'll either get a heads or you'll get tails. Now, after we flip a coin, we are asked to go ahead and roll the number cube. So I flip a coin. Let's pretend I flip a coin and I get heads. After I flip the coin, I can roll the single dice and I might roll a 1. In which case, my sample space would say, I rolled heads, and then I got the number 1. Or maybe I get heads first again, but instead of a 1, I get a 2. In which case, my sample space would say heads and then 2. And you can repeat the same process for 3, 4, 5, and 6. And you'll have heads 2, heads 3, heads 4, heads 5, and heads 6. But there's also another possibility. When I first flip that coin, it's possible that I get tails. In which case, I can get tails first and then roll my die and get tails and the number 1. Or I can get tails and then roll the number 2. So my sample space would say tails 2, and then tails 3, and so on and so forth. Count how many total possible outcomes we have. 1, 2, 3, 4, 5, 6, or 7, 8, 9, 10, 11, 12. Any of these outcomes. So the tree diagram would show that there are a total of 12 possible outcomes. And here's what your diagram should look like. We have all the choices on the number cube, a standard number cube, 1 through 6. We had the coin flip first, heads or tails. Then you rolled one of these numbers. And here are all the possible combinations. There is nothing outside this set of combinations possible as long as you do these 2 events in this order, coin first and then number cube. Now, let's go ahead and work on creating our own and discussing this furthermore on the back of this page on page 366. So let's go ahead and flip the page over and let's go right to the top. On the top, we're going to be focusing on these 3 investigation questions. It says use a list or tree diagram to show the sample space for each action. You'll be working with your partner for this. Now, here we have a spinner. The spinner is divided into 3 sections, as we can see here. So my sample space would be the list of all the possible outcomes. If I spin that spinner, what can I get? And we can either spin in the yellow section, in the red, or in the blue. Since they're all the same size, then we have an even chance of getting any one of those 3. So we can spin yellow, red, or blue. But if you noticed, not only is each section given a color, they're also given a letter. So we can also spin either an A, a B, or a C. So our sample space should say yellow, red, blue, A, B, C. So in this case, we have 6 possible outcomes for this sample space. Over here, we're going to create a tree diagram. And there is an edit we have to make. There's a line missing on this tree diagram. And if you would, with your pen or pencil, go ahead and draw the line in right here, because there should be an extra space. For some reason, it didn't come out. Hopefully, your line will look better than mine, being that you guys have a straight edge and not doing this digitally like I am. So going back to this explanation, we're going to toss a single coin or a coin 3 times. And we're going to make a tree diagram. So let's flip the coin the first time. We can get either heads or tails, and that's what you'll write right here. Then we can flip the coin again, and we can get either heads or tails again. If we flip the coin a 3rd time, we can also get heads or tails, in which case our sample space could read heads, 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 if we follow the top part, or heads, tails, heads, and you get the idea, kind of like what we did before. You should see here we should have a total of 1, 2, 3, 4, 5, 6, 7, 8 in our sample space. Now over here finally we have a 3rd spinner. We have 1, 2, 3, 4, 5 equal parts, so everything is fair. And we notice that each section is given a color: yellow, green, red, purple, and blue. Notice that there's also words written, but the words describe the color, so there is no extra options. So when you spin this spinner, our sample space, all the outcomes would be listed yellow, blue, purple, red, green, in any order. So we only have 5 choices here. When we flip a coin 3 times, we had 2, and then 2 more, and then 2 more, for a total of 8 total. And then we had a spinner over here with 3 colors and 3 letters for a total of 6. So you can't just always go by looks. You have to ask yourself, what's happening in my experiment, before you can figure out how many outcomes you'll be able to predict. When you complete this whole part here, it should look like this. And here they used abbreviations because using the words would be taking up too much space, and I totally am for that. So if you're going to go ahead and use capital letter abbreviations, go ahead and do that. Just make sure they're all capital, please. So now, you did this. There's a very important question I want you guys to consider, and it's this next one. It says, look at number 2 up here above. Analyze the relationship between the number of outcomes for each coin toss. Well, how many things could we get from a coin toss? We can get 2 things. We had 2 outcomes, heads or tails. How come when we tossed a coin that has 2 outcomes 3 times, we get a total of 8 outcomes altogether? Can you explain that mathematically? If you can, then you are above and beyond where you need to be with this lesson. If not, maybe you should ponder that, because it's probably going to be asked very soon. Now, we're going to take this worksheet and we're going to do a little project with it. And let me go ahead and change my screen up a bit here. Let me go ahead and bring this into view for you guys. All right. Let's see if I can expand on this. Actually, let me just bring my window in a little more. Should be no big deal. Or maybe it will not let me. I really don't know. Okay, so let me go ahead and just bring this down just a bit into my view. All right, so you guys are now going to work on a mini little foldable for me. You need a couple of things. First, you are going to need your worksheet from your workbook. You can go ahead and tear it out if your teacher lets you. And then you should be completed. You should have on page 365 this whole tree diagram completed. And you should have over here on this side, you should have numbers 1 through 3 and hopefully even number 4 answered. Let me zoom in a little bit so it looks a little more crisp and clearer, hopefully. And while it adjusts there, let me see if I can zoom in a little more, make it look a little better. Maybe not, but anyways, you guys get the idea. Next, you're going to need another document that will be passed out to you, and that is going to be a copy of the diagram from page 365, and upside down on the same page is the copy of the diagram on page 366. You're going to go ahead and recreate the data you got here from the worksheet onto both of these charts, and then you're going to cut them out. You will then have this document here. This is a foldable. Let me go ahead and zoom out a little bit. You're going to get a paper that looks like this, and it's going to be double-sided. It has all these boxes. It says tree diagram on the bottom of one side, and then it has these other boxes on the other side. On the bottom, there's a place for your name, the date that this is going to be assigned, and the period for your class. Go ahead and fill that out as well. And what you're going to do first is turn it back over to the other side, and we're going to go ahead and write some data in. Here on the top in these boxes, you have the words event, outcome, and sample space. Now, the only thing that wasn't in this lesson was the word event. So I'm going to go ahead and give you that definition. And the definition for an event is going to be any action that produces outcomes. Yes, if you didn't notice, my fingers are blue because right before this recording, my dog decided to go ahead and eat one of these blue pens. And before I threw him out, I realized I had blue all over my hands. So please forgive me if I get any stains from here on out. Back to the lesson. Now, you're going to refer back to your worksheet and define outcome, sample space, and tree diagram here in these boxes. You'll write out your answers. And I color-code everything because I want everything to look nice. So for my lesson and for my foldable, anything that had to do with events was color-coded, pink or red. Outcomes were orange, sample spaces were green, and the tree diagram data would be blue. That's just how I did it. I'm not sure coloring is going to be necessary, but you know, it helps and makes things look nice for this. Take some pride in your work. So after you've defined all three of these things, you're then going to get one of your cutouts from the first paper I showed you, and you're going to go ahead and glue your tree diagram from page 365 into the space below. You should have all your data filled out here along with your definitions up here. After that's complete, you're then going to turn it over, and you're going to turn your paper upside down and write the words event, outcome, and sample space, because those are 3 of the 4 words we learned today's lesson. Our topic is probability, and this lab was about sample spaces. Once again, I went ahead and added color and kept everything nice and consistent. Finally, you're going to turn that paper you just worked on over upside down, and you're going to glue that second chart that you have on your paper with your data filled in here also. Make sure you have everything correct, nice and neat and organized. You're going to cut it to fit. And finally, when you're done, you're going to go ahead and fold your paper over where the vocabulary is like this. Fold that paper and fold it right to where this line is right above tree diagram. And then now you have a nice little foldable for some notes that you can use on any quizzes or tests from this week. The front should look pretty much like this. The back should have your chart. I'm not going to stop because I don't want you to see any answers. And there you go. All right. This will be due by probably by beginning of class tomorrow. Good luck, guys.